are back with our classes on physics, that is electricity. It has been a pulling chapter, I don't know why. Let us see if this week we could finish it and then start with our I and the colorful world. We were doing problems based on commercial unit of electricity where power is converted into kilowatt and time is converted in hours, or time is kept in hours because 1 unit will be equal to what? 1 kilowatt hour. So the second problem basically which we have to do, let us write an electric lamp. What is the problem number 20? 11. So we have an electric lamp is rated or is marked 100 watt 220 volts. 100 watt 220 volts. It is used for 5 hours daily. It is used for 5 hours daily. Calculate a resistance while blowing and B energy consumed in kilowatt hours daily. Energy consumed in kilowatt hours daily. This is the problem which we need to solve. It says an electric lamp is marked 100 watt 220 volts. 100 watt in the end. P is 100 watt. What is V? V is 220 volts. It is used for how many hours? 5 hours. So T is how much? 5 hours daily. Okay. Now what they are asking us to calculate? Calculate resistance while blowing. So I need to find out R. And I also need to find out electrical energy. Isn't it? So now in the side we will write formula. P is equal to VI. P is equal to V square by R. P is equal to I square R. And P is equal to E by T. I need to find out R, but I don't have I. So which formula I will use? Second one, which is P is equal to V square by R. V is 220 into 220, sorry. P is given as 100 watt and I need to find out what? R. So R is equal to 220 into 220 by 100. 22 into 22 is to pass 484. 484. So please write R is how much ohms? 484 ohms. Okay, now what I have to find out? E. So P is equal to E by T. So E is equal to P into T. P is how much? 100 watt. Convert it into kilowatt divided by 1000 into how many hours? Into 5 hours. This goes 5 ones are 5 twos are. So 1 by 2, that is equal to how much? 0.5 kilowatt hour. So the total energy consumed in kilowatt hours daily is 0.5 kilowatt hour. Understood? Simple, but always understand these formulas you should know. If you don't know these formulas, then you will end up in a mess. So please always write towards the side which formulas of power we know. Let us do the next one, the 12th problem. A heater rated is connected to a 220 volt supply. To a 220 volt supply, calculate the resistance of the heater and the current flowing through the heater Okay. So again, what is given to us? We have P is 250 watt. So we will write P is 250 watt. Your V is 220 volts. Calculate the resistance of the heater and the current flowing through the heater. I need to find out R and I need to find out I. So which formula? P is equal to VI. P is equal to I square R. P is equal to V square by R. So let us first try finding out I. So P is equal to VI. P is 250 watt. V is 220 volts and I need to find out I. So 250 by 220 is equal to I. Cancel it. 25 by 22 is equal to I. Divide please. 25 by 22. 1 point something. 1.1. Isn't it? I think 1.1 only. 1.13. 1.13 amperes. So this is what I have got as I. Now I need to find out R. So I can use the formula V is equal to IR. So V is 220. I is, let me keep it as 25 by 22 into R. So you will get 220 into 22 by 25 is equal to R. You can cancel by 5. I think 5 5s are 25, 5 44. Then I don't think it's possible. You will have to divide. So 44 into 22 divided by 5. Please divide and get the answer. I think how much? 193.6 kilowatt hour is your R. 193.6 kilowatt hour is kilowatt, sorry, this is the resistance, I'm sorry, it is ohms. 193.6 ohms is your resistance. So simple problems where you use direct substitution of power and resistance. Now for the next one, the 13th problem. Let us do the 13th problem. We will try an electric motor takes 5 ampere from a 220 volt line. From a 220 volt line. Determine the power of the motor Determine the power of motor and electrical energy consumed by it in 2 hours. Okay, so this is our problem. Now, this is given as what? I. I is what? Ampere? 5 ampere. B is given as what? 220 volts. Calculate P. I have to calculate and the electrical energy when time is given as how much? 2 hours. So first, let us find out P. P is equal to VI. So P is equal to 220 into 5. So 0, 5 to the 10, carry on 1, 5 to the 10 and 1, 11. So you get what? 1100 watts as your power. Electrical energy consumed by it in 2 hours. So P is equal to E by T. So E is equal to P into T, where P is how much? 1100 by 1000. Why? Because we want it in kilowatt hour. Time is how much? 2 hours. 2 ones are 2 5s are 10. 11 by 5 multiplies to 2 point something. 2.2. So you get 2.2 kilowatt hour. Is 2.2 kilowatt hour. Okay, now for the next one. This is 14th problem. Is right. 14th only, no? An electric iron of resistance resistance 20 ohms takes a current of 5 amperes. Takes a current of 5 ampere. Calculate the heat developed by it in 30 seconds. In 30 seconds. Okay, now this is a problem based on Joule's law of heating. You have R given as 20 ohms. You have I given as 5 ampere. Time is given as 30 seconds. What is Joule's law of heating? H is equal to I square RT. H is equal to what? I square RT. So H is equal to 5 into 5 into 20 into 30. So it is 25 into 20 into 30, which is equal to how much? $15,000, isn't it? 15,000 joules, or you can write this as 15 kilojoules. 15,000 joules or 15 kilojoules. Okay, now the next one, the 15th one. have we done? What is the highest and the lowest total resistance? Please check once. Resistance is combinational ಮಾಡಿರೋ ಜಾಗದಲ್ಲಿ ನೋಡಿ. What is the highest and lowest total resistance with 4 ohm, 8 ohm, 12 ohm and 24 ohms? ಮಾಡಿದೀವಾ? Next ನೋಡಿ. How can two resistors be connected of 2 ohm, 3 ohm, 6 ohms to get 4 ohms and 1 ohm? Because I think most of the resistance problems we have done before. Have we done? Illa? Okay, then write this. Please write the next problem, the 15th problem. How can three resistances of 2 ohms, 3 ohms and 6 ohms. How can three resistances of 2 ohms, 3 ohms and 6 ohms be connected to give a resistance of A 4 ohms and B 1 ohm. Textbook problem ಮಾಡ್ಸಿದ್ದೀನಾ? Okay. So you already have done it, but once again I will explain. 2 ohm, 3 ohm, 6 ohms means it should all be connected in parallel because it is lower than the least resistance. You will connect 3 and 6 in parallel. So you will get what? 1 by 3 plus 1 by 6. So LCM 6. 2 plus 1, you get 3 by 6, which is 6 by 3. It will become what ohms? 2 ohms. 2 ohms and another 2 ohms in series will give me what? 4 ohms. Okay? So this we have finished all or most of the problems based on which I needed to teach. Now please come to page number 220. Come to page number 220. I think the second problem we have just now done. Have we done this problem? Just check. 5 ampere 220 volt line, determine the power of the motor and the energy consumed in 2 hours. I think just now before this or before that someone one problem I would have done this problem. Just check. Done? Okay. What determines the rate at which energy is delivered by the current?
Electric power.
Electric power. Please write. What determines the rate at which energy is delivered by the current? Electric power determines the rate at which electrical energy is delivered by a current. Okay. Now we have exercise problems. We will go from behind as usual from 18th problem. 18th problem, 18th is a very important question. So most of it I have done and it is there in your notes. Why is tungsten used almost exclusively for filament of electric lamps? Because tungsten is a metal which has high melting point of 3380 degrees centigrade. It does not oxidize at high temperature. So we use tungsten. Why are conductors of electric heating device such as bread toasters and electric irons made up of an alloy rather than pure metal? The resistivity of alloy is more than metal and hence they do not oxidize at high temperatures. So we use, I think this is there in the notes also given written. Okay. Why is the series arrangement not used for domestic circuit? In series arrangement, every appliance has got the same current flowing through it. In series circuit, it is not possible because different appliances require different amount of current. And second thing, you will also find that if one of the device stops working, then the entire connection will go off. So I think somewhere down the lane we have written advantages of series and parallel circuit. That way the answer has to come. How does the resistance of a wire vary with area of cross section? It is inversely proportional to the area of cross section. More the area, less the resistance. Why are copper and aluminium wires usually employed for electricity transmission? Because they are good conductors of electricity. Clear? Tomorrow I expect you to write all this in your notebook. Fine? Every day we will do 2 problems and finish it. I also expect you to solve the first 4 questions. I also expect you to solve the first 4 questions, 4 objective type questions, which will help you to get an idea of it. After that, I will do all the problems behind. So I expect you to write this in your notebook. Even if you have written before, please rewrite exercise questions at the question number 15 bariri. Naaleಯಿಂದ ನಾನು 2-3 problem ಮಾಡಿ ಮುಗಿಸ್ತೀನಿ. Okay? So we will now start with chemistry. Thank you so much.